Hello guys, I hope you're fine and welcome to module 6, and that is file handling. So throughout this module we are going to look at 4 subsections, and subsection 1 will entail reading and writing text files, and subsection 2 will entail working with CSV files using CSV module and pandas module. And subsection 3 will entail JSON files using JSON module. Whereas on the last section on pickling will entail pickling module. So stay along as we move ahead to practical section. Hi guys, in this section we are going to look at module 6, which entails file handling comprehensive guide. So this module covers text files, CSV, JSON, and binary serialization with detailed explanations, practical examples, and format tips. So part 1 we're going to look at text file fundamentals. So they are the most form of file storage. They are human readable form or format. And the common encodings include UTF-8, which is default, ASCII, and Latin 1. So line encodings vary by operating systems such as Unix, Windows, macOS, and more. So we're going to look at basic file operations. So number 1 is writing to a file using context manager, which is recommended. So by the way, what is a context manager? A context manager in Python is a powerful construct that help manage resources such as files by automatically handling setup and tear down actions like opening and closing of files. So in file handling, a context manager is used via the with statement, as we shall look with the examples. So context manager automatically closes file even if errors occur. So with the statement creates a context manager which ensures proper setup and cleanup of the file resources. So open, for example, diary.txt W mode, so which means in write mode, so and encoding is equal to UTF-8. So this one opens or creates the file name diary.txt in write mode, and encoding UTF is equal to 8, and ensures that the text is written in UTF format, which supports a wide range of characters. As file assigns the opened file object to the variable file. Hello guys, we're going to look at example 1. So with open diary.txt, we are going to write something, and encoding mode is UTF as file. So file.write diary, dear diary. So, and remember /n is for new line. So file.write, I write the given string to the file, so it will write dear diary. So and /n adds a new line character. So the next line starts from a new line. So file.write, we want to add, today I learned Python file handling, for example, and this line writes the next line of the text to the file, and this file is called diary.txt, followed by a new line. So file.write key points. So we want to write key points to the same file. So this one writes another line indicating a list is about to begin. So file.write lines. So we can write context managers safest, for example. They specify encoding for reliability, and they have different modes for different needs. Remember, file.writeLines function writes each string in the list to the file as is. So since each string already ends with /n, each bullet point goes on its own line. So files files.py, and we run and realize that our program ran successfully, but you can't see, I weren't able to see anything from the terminal. So let me go back to the file tree or working directory section, and you find that we have a new file called diary.txt. If I open it, I find that, dear diary, today I learned Python while file handling, and these are the key points. Context manager are safest, and we specify encoding for readability, and they have different modes for different needs. The way we just wrote here, from here, dear diary, today I learned Python file handling, key points, and then those key points are here. So I hope this is clear. So let us move ahead. Example 2. So we're going to look at example 2, and this entails reading methods. So we have like three ways to read through a file. So we already have our file called diary.txt. So we still use the context manager with open diary.txt in read mode and encoding UTF-8 as a file. So method 1, read function reads the entire file content into a single string. So content is equal to file.read. So that's our object. So we can print full content. So this is just our stuff that you would like to be printed after running the content. So we can also print the content. Now this one resets the file pointer to the beginning of the file using the seek function. So this is necessary because read function moves the pointer to the end. So file.seek 0. Then method 2 of read lines entails reading one line at a time. So for example, print line by line, and line is equal to file.readLine, for example, and while line, we need to print line.strip, which means we are stripping or removing the leading or trailing white spaces and new line characters. So line is equal to file.readLine, and this one resets the pointer again before using a readLine method. So file.seek 0, again we reset our file. And method 3 of read lines entails reading the entire file and returning a list of lines. For example, lines is equal to file.readLines, and if we print our line list, we get as print is equals to print lines. Now let me run files.py, and we get our output. Voila! this is our output, whatever we've been writing. The first example, the second example, and the final example. Yes. So example 3 entails appending to existing file with open, for example, dart.txt. We need to append in append mode as a file. So this one open the file in append mode. So we want to add something on that file. So the new content is added at the end of the file, and if the file doesn't exist, then it will be created automatically. So this one is dangerous because it will truncate your file, so it will add its own content. So remember, encoding still UTF-8, and this one will ensure that the file supports a wide range of characters, as said before or previously. So we're moving ahead. File.write. So for example, entry 1, this one adds a new entry header on a new line. So, and remember, /n or /n ensures it is separated from any existing contents. So file.write, for example, we want to add something like now learning advanced file operations. So this one appends another line under the new entry. So let me run the code and see what happens. We find out that the program ran out successfully. So we check the output. Now remember, the output is here. So something was added to the file. So entry is entry 2, and now learning advanced file operations. So which means everything's working. Yes, guys, I hope you are enjoying this. Hello guys, now here are some tips. So file modes, deep dive. So we're explaining the file modes, and we're explaining the file modes and availability in Python for file operations. So for example, R is read mode, which is by its default, so, and it must exist, the file must exist. So the R mode opens the file for reading, and the file must already exist in your working directory. Otherwise, you will get an error which will be raised. And W mode, which means write mode, will create or truncate the existing file. So, and remember, W mode opens the file for writing. So if the file exists, it will be truncated or cleared. Otherwise, it will create a new file. So A or append mode creates or appends. So A mode opens the file for appending, and if the file exists, new content will be added to the end without overwriting the existing content. On the other hand, X or exclusive creation fails if exists. So X mode creates a new file, but it fails if the file already exists, so it will not overwrite. So, and R plus mode, it will read or write, and it must exist. So R plus mode opens the file for both reading and writing. So the file must already exist, otherwise an error will be thrown. So, and W plus means read/write, which creates or truncates the file. So W plus mode opens the file for both reading and writing. So, and if the file exists, it will be truncated. Remember, truncation means clearing, otherwise it will be created. And A plus mode or read and append mode will create or append. So A plus mode opens the file for both reading and appending, and if the file exists, then it will append to it, otherwise it will be created. And B mode or binary mode, e.g. RB or WB. So B mode will open the file in binary mode, and it is used when reading or writing non-text files, e.g. images, executable files, etc. And T mode or text mode is a default one. And remember, T mode opens the file in text mode with default operator. So it handles encoding and decoding text automatically. So guys, remember we've just covered a snippet of file handling. So I've given you a way forward to do more research on what we've not covered. So I wish you all the best as you do more research. So let's move ahead. CSV files. So CSV files are just comma separated values, and they are standard format for tabular data. And remember, each line represents a row, and columns are separated by delimiters, usually called commas. And first row often contains headers and handles special cases such as quotes, escapes, among others. So this is how to use CSV file. So we start by importing the CSV module as follows. So import CSV. So we're going to have some data to be written to CSV file, such as data is equals to name, for example, age, occupation, and salary, for example. Those are column names. So name, for example, Mary is 32 and is a data scientist, for example, and earns 95,000 USDs per year. And Bob is 28, is a web developer and earns 87,000 per annum. And David, for example, is 45 and is a CTO or Chief Technology Officer and earns 125,000 USD. Now guys, let us see how to write to a CSV or a comma separated file that we have just created. So with open employees.csv, so we are opening it in write mode. So this one, we open the file in write mode with the UTF format or with UTF encoding, and this one will prevent blank lines on Windows using new lines. So writer is equal to csv.writer. So that is, I have three parameters: file delimiter, quote r and quote.cv. In fact, there are four parameters. So we need now to create this one creates a CSV writer with comma as delimiter using minimal quoting. So writer dot write rows data. So our data is called we created above. So this one will write all rows from the data list into the CSV, that is employees.csv. So and this one will include both the headers and the rows. And after, remember, the headers are just like columns, and after the block exists, then the file is automatically closed and data is saved. Now let me run the program so the file can be saved. So files.py, and then I run. Yes, now I believe the file is saved. That's employees. Yes, it's here. Employees.csv. Here it is. So let us move ahead. So we're going to see how to use CSV files using a dict reader or a dictionary reader. So we start using our context manager with open employees.csv that we've just created. I want it to be in read mode and using UTF encoding as a file. So this one will open the written CSV file in read mode. So reader to be our object is equal to csv.dict reader, and we pass on the file as the argument. So the dict reader reads rows as dictionaries using the first row as column names, so we can print our stuff. So and each record will be printed in a different row or a different line. So for row in reader, which means each row is a dictionary where keys are column names and values are cell values. So we want to print the row name to row occupation and earning. So we want to print the name, occupation, earning, and salary. So for example, this one will be optional, but you can check if the employee is higher earner than another. So if in int row, that is salary, is greater than 90,000 USDs per annum. So, and we have to print, if we find that it is true, then we have to print as higher. So let me run the code and see what happens. Files.py and run. So we find that the employee data has been printed, this line number 50, and which means we will read this one. And Mary, for example, data scientist earning 95 USDs per annum, and she is the higher earner. And Bob is a web developer earning 87,000 USDs per annum. David, on the other hand, is a CTO, or Chief Technology Officer, and he earns 125,000 USDs per annum. And also he is also a high earner because we've modified our code that anything above in salary above 90 USDs should be printed as higher earner. So that's why you're getting higher earner and this one higher earner. So let us move ahead, guys. Writing to tab separated values, or TSV. So we have our examples in context manager with open employees.tsv. We want to open in write mode, and encoding is equal to UTF-8 as file. So this one will write the same data into a TSV tab separated value alternative format. So for example, our object is equal to writer is equal to csv.writer file delimiter as our parameters, as then this one means that we are using tab as delimiter. So writer.write rows data, and we're giving it a new line. So again, all rows from the data list are written, and the file is closed after writing automatically, and data is saved. So let me run our code. Compile files.py. We find that the previous result are produced. However, let us check our file history. We find that we have employees.csv data has been created. So pandas approach for large data sets. Now guys, let us look at advanced CSV operations. So for example, our data frame bonus, we want to create another column called bonus to our data frame. So you call data df salary dot apply lambda int x2 like 0.1, and this one means that we are adding 10% bonus column. So, and we want to save our data, our new data frame. Hi guys, we wanna look at how pandas does large file handling in chunks. So for example, we want to define a placeholder, a function that will be used for large data set processing using pandas. So we define the process function that will take chunk as the parameter, and this one will be used for handling large files in chunks. So we need to print our own message that the processing chunk with now, which means the length of the chunk, and which means the rows, the number of rows of the chunk file that will be produced. So for example, we define our chunk size as is equal to 10,000, and for chunk in chunk, also sorry, for chunk in pd.read csv file large data set. So chunk size is equal to chunk size, which means at 10,000. So we can print the process. So for example, in use, we can print the first row as print chunk dot head. That is the first row. Hi guys, let us move at number 3, where we're going to look at JSON files. So remember that JSON is just a shorthand for JavaScript object notation, and it has the following properties. It's a lightweight data interchange format, and it's human readable as well as machine passable, and it supports nested structures. It's also a native Python type that includes dictionary, list, str, int, float, boolean, and none. So let us use JSON now. So we import JSON, and this will also create a complex nested data structure shortly as follows. So for example, the company information is equal to name is equal to TechCo, and was founded in 2010, and departments include engineering, head for example is equal to Ali, size is 45 individuals, and skills for example Python, Java, DevOps, and you can also have marketing department as follows. So head of department is Bob, size is 12 individuals, budget is 500,000 USD, etc. So public is equal to false, and revenue is equal to none, for example, which means painting a financial report. This is how we create an object using JSON. Hi guys, let us see writing JSON with pretty printing. So using file context manager with open company.json in write mode, encoding UTF-8 as file. So json.dump company as parameter, file intent is equal to 4, and sort keys is equal to true. So let us explain what's happening. So first of all, we open the file in write mode with UTF-8 encoding, and second, we use JSON dump function to write the company dictionary to the file, and we use indent is equal to 4, which makes the JSON output human readable with indentation that is understandable. So we use also sort underscore keys is equal to true, which writes the dictionary keys in sorted order. So reading and modifying JSON file. So with open company.json, we are opening it in read mode, and encoding is the same UTF-8 as file. So this one we are opening the JSON file in read mode with UTF-8 encoding. So our data will be json.load file. So this one loads the JSON contents into a Python dictionary. And now data, departments, engineering, size is equal to plus equal to 5. So we are incrementing by 5. So this one we are modifying the data, and we are increasing the size of the engineering department by 5, e.g. new hires. So let us look at custom JSON encoder or decoder example. So we define a custom class to represent an employee. So for example, class employee is such that we define the method as init self name and ID. So an employee will take name and ID. So we are initializing an employee object with a name and an ID. So self.name will be name and self.id will be ID. So let us define a custom encoder function for employee object. So for example, define employee encoder as a parameter will be object. So if instant object and employee, then it means that this, if the object is an instant of employee, then we need to return a dictionary representation. Else we need to return a dictionary representation. We are going to return the name as object.name and ID will be object.id. So if not, we'll have to raise an error in indicating it is not serializable. So raise type error object of type object dot underscore class underscore dot underscore name underscore is not JSON serializable. Now let me run the program py files.py and run. We find that nothing happens, but if I maneuver to my file tree, I find that we have JSON company.json file here that it was created by the codes we've been running. So this is how you can use Python to manipulate files. So let us move ahead. Hello guys, now it's part to move on part 4 of module 6. So and it will entail a binary serialization, that is pickle. So we need to import the pickle module for binary serialization. So import pickle. So that module is being built. So this we are defining now a class to hold the research related data. For example, class research data, and we're creating a constructor method to initialize the object with an experiment name. So our method def underscore underscore init underscore underscore with parameter self experiment name. So self.experiment is equal to experiment name, and this one will store the experiment name, and self.sample or samples will be an empty list to hold samples. So self.result will be an empty dictionary to hold the calculated statistics. And we also have method. We want also to define the method to add a sample to the sample list. So def add samples self sample. So self.samples dot append, and now we're going to append to our initial samples. And also we want to define the method to calculate statistics and store them in results. So for example, we def calculate statistics. So remember to use descriptive words. So self.result mean is equal to sum self.samples over length self.sample. So we are calculating the average, and self.result max is equal to max self.samples. This one will find the maximum values in our data set. Now we want to look at how to serialize complex objects. For example, data is equals to research data. So protein folding. So here we're creating an instance of research data with a specific experiment name. So data dot add sample, for example 12.5. so this one we're adding a sample value of 12.5 to the sample, the samples that are listed. So we can also data dot add sample 14.42. so we are also adding another sample equivalent to 14.2, and data dot calculate statistical stats, which means we are creating a function to compute statistics such as mean and maximum based on the function that we defined. Now we want to look at serializing the data object to a binary file using a pickle. So for example, with open experiment.pkl wb, so which means in binary mode or in pickle mode, we open the file. This means that we're opening the file experiment.pkl in write binary mode. So pickle.dump, it will take 3 parameters: data, file, pickle protocol is equal to pickle.highest protocol. So this means that we use the pickle.dump function to initialize the data object into the file, and now the highest protocol is observed or is used for the most efficient binary serialization that is available. So attempting to deserialize the data from the pickle file with version checking. So for example, we try. So with open, so experiment.pickle, so rb as file. So we are opening the file in the file called experiment.pickle in read binary mode or rb, and now loaded data is equals to pickle.load file. So we use the pickle.load file to deserialize the data from the file, and we load it into loaded data. So we can print the loaded experiment to loaded data.experiment. So here we're printing the experiment attribute from the loaded data, and as well we can print result from the loaded data, which is loaded data dot result. So we do print the result attribute from the loaded data. So except pickle dot unpickle error as E. So we're trying to catch any errors during the serialization process, e.g. if the file is not a valid pickle file. So we print error loading pickle file. So and we show the error to the user. So we print the error message back to the user if an exception occurs. So let me run the file or the program and see the result. So we find the result as loaded experiment is protein folding, and result is, for example, mean is 13.35 and maximum value is 14.20. So let me pursue through here, and we found out that this is the entire code that we've been going through. Everything is here, so I call upon you to pause the video and try to rewrite the codes, and as well as run them and check if your output are also producing the same result as I'm also getting the result. Hello guys, let us look at some security checks. So for untrusted data, consider alternatives such as JSON. JSON will be used for symbol data structures, and Marshmallow for complex validation. You can also use H5Py for scientific data. So you can do some research to understand what's happening, what is I'm talking about. So this is the summary of what we've been doing in this files module. So text files have the following features. They are basic input-output operations. They have multiple reading methods, and they also use context managers for safety. And when moving to CSV files, we find out that they are standard library for symbol cases, and pandas is used for complex or large datasets. And we can also do chunking for memory efficient. And moving ahead, JSON on the other hand, they have the following characteristics. They are ideal for configurations. They also support nested structures, and they also have customized serialization accessible. So moving ahead on pickle, we realize that they're Python specific binary format, and they handle complex objects, as well as they are used for security considerations in critical situations. And now module 6 is coming to an end. So your data persistent toolkit is now ready and it's in your hand. So you have some practical ideas that you can work on, such as you can build a contact manager with a CSV storage. You can also create a settings system using JSON, as well as you can do serialization using a complex object hierarchy with pickle module. I wish you all the best, and kindly subscribe to our channel. Thank you for watching our videos. See you in module 7.